Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling question number 7 from the mid-year examination which was written in the province of Mpumalanga in the year of 2024. Please do expect a total number of 8 videos since the question paper had 8 questions in total. And please guys, do take this seriously, because knowing how to tackle exam questions, I strongly believe it will give you an edge whenever you write your mid-year exam, your preliminary exam, and most importantly, your final examination. So please do share the video to your peers so that they may have the same edge as you. And please guys, do help us grow the channel by just subscribing. Okay, question number 7. We are given f of x, and then we are told that point T is a stationary point, and we are told that f of negative 3 is equal to 0. And then we are told that A and B are both x-intercepts. This statement over here, guys, f of x is only equal to 0 at the x-axis. Are you together? So since I only have one negative x-intercept, that means the coordinates of A are the ones which are just negative 3 and 0. Yes, I'm given the coordinates of t, but let me change this mixed number into an improper fraction. How can I do so? On my numerator, I'll simply write 27 times 18 plus 14. This is all divided by 27. That's how you express your mixed number as a proper fraction. So the coordinates of t, they can be written as negative 4 over 3, as well as 500 all over 27. 500 over 27. These are the coordinates of t. Now, first question, they want us to show that p is equal to 8 and q is equal to 12. Since I'm given the equation over there, f of x is equal to x cubed. Let's find the value of p first. X cubed minus x squared minus px plus q. My derivative will simply be equal to 3x squared minus 2x minus p. But remember that, guys, the derivative of a curve is always equal to 0 at the turning point. So my derivative will be equal to 0 if and only if x is negative 4 over 3. Why am I choosing negative 4 over 3? Because I know that at position t, which represents my turning point or the stationary point, the derivative is always equal to 0. Okay, I now know that, okay, the derivative will be 0 if and only if x is equal to negative 4 over 3. So let me just substitute that x value on my derivative. Negative 4 over 3 squared minus 2 times negative 4 over 3 minus p is equal to 0. Let's check. What do we have? I have 3 multiplied by negative 4 over 3 squared minus 2 times negative 4 over 3. So this will simply give me 8 minus p is equal to 0. Therefore, p is equal to 8. Now I do know that the value of p is equal to 8, right? For me to find the value of q, I must just substitute the extra point I have on my graph. I know that f of x is equal to x cubed minus x squared. Now I know that p is equal to 8, so that's negative px plus q, right? I know that y is 0 if and only if x is equal to negative 3. If and only if x is equal to negative 3. So the corresponding, the value of q will simply be, okay, I'll simply have 0 over there, negative 27 minus 9 plus 24 plus q, then 0 is just equal to negative 12 plus q, then q is just equal to 12. So I now know that p is 8 and then q is 12. I've proven that. The next question, they want us to show they want us to find the distance of AB. Ne? Both A and B are just our x-intercepts. Are you together? Both A and B represent are both on the same horizontal line. So for me to find the distance between A and B, I just need to find the x values and then subtract them. How can I find the coordinates of B? By just finding the x-intercept. For me to find the x-intercepts, guys, I know that y is always 0. So I'll simply say x cubed minus x squared, f of x, which is x cubed minus x squared minus 8x plus 12 is equal to 0. I know one of the factors, guys. X plus 3 is a factor. Are you together? X plus 3 is a factor because I was given one of the x-intercepts. I just need to find that one over there. So for me to find the values there, I just need to divide the first terms. This one divide by that one. I'll simply get x squared, and then positive 12 divided by positive 3. This will give me a positive 4. For me to find the middle term, I'll simply take this value over here, minus x squared minus the product of these two. So it will be minus x squared minus x squared minus 3x squared. This will simply give me negative 4x squared. But whenever I write my answer, guys, I'll never write it as negative 4x squared. I'll just write it as minus 4x. I have x plus 3. Okay, I want the factors of 4 that when I add will give me 2. That will give me 4 rather. That's just 2 and 2, minus and minus. So x is equal to negative 3, or x is just equal to positive 2. So since over here I have negative 3 and 2, and over there I have 2 and 0, therefore the length of AB, the y values are the same, guys. Both of them are equal to 0. I just need to subtract the x values. So I'll simply say 3 minus, not 3 rather, but 2 minus a negative 3. This will give me 5 units. Are you together? 5 units. AB is just equal to 5 units. Now I must find for which values of x is the function concave up. The function will be concave up if and only if the second derivative is positive, or rather is greater than 0. If the second derivative is greater than 0, okay? If f of x is equal to x cubed minus x squared minus 8x plus 12, therefore the first derivative will be 3x squared minus 2x minus 8, and the second derivative will simply be 6x minus 2. Are you together? And my graph will be concave up if and only if the second derivative is greater than 0. So 6x minus 2 is greater than 0, then 6x is greater than 2, x is greater than 1 over 3. So my function of x will be concave up when x is greater than 3. Okay, now I'm supposed to determine the equation of a tangent to the curve. Determine the equation of a tangent to the curve at a point where f of x changes its concavity. F of x changes its concavity, guys, at the point of inflection. And I know that at the point of inflection, the second derivative must always be equal to 0. And whenever the second derivative is equal to 0, therefore, the x value will just be equal to 1 over 3. Because the very same thing I did over here, guys, I'll repeat it, but now I'll just replace the greater than sign with an equal sign. Are you together? And hence will be equal to 1 over 3 whenever at a point where the function changes concavity. Remember that, guys, the function changes concavity at the point of inflection. For point of inflection, the second derivative is equal to 0, and then that will give you your corresponding your x value at the point of inflection. For us to find the y value, we must go back and substitute on our original graph the value of x so that we can find the corresponding value of y. Right, together. So how can I find the corresponding value of y? That's negative 4. That's 1 over 3, the x value at the point of inflection, cubed minus 1 over 3 squared minus 8 times 1 over 3 plus 12. So this would basically give me 250 all over 27. This is the point where the graph changes its concavity. I want to find the equation of a tangent, right? After finding my point, I must go and find the gradient. Gradient is basically a f prime of x when x is equal to 1 over 3. So that's 3 times 1 over 3 squared minus 2 times 1 over 3 minus 8. So the gradient is basically equal to 3 times 1 over 3 1 over 3 squared. What am I doing now? 1 over 3 squared minus 2 times 1 over 3 minus 8. So this will just give me negative 25 over 3. So this will be the gradient. Now, for me to find the equation of a tangent, I just need to find a point on the graph as well as the gradient. Let me use a different color. I know that y is equal to mx plus c. Y is equal to negative 25 over 3x plus c. Now, for me to find the value of c, I just need to substitute the x and y values. I do have a point. I know that y is 250 all over 27, and then x 25 over 3. The x value is just 1 over 3 plus c. Therefore, c is equal to 250 over 27 plus 25 over 3 multiplied by 1 over 3. This will just give me 325 over 27. This is my y-intercept. So therefore, the equation of a tangent, let me write it in green. Y is equal to mx plus c. My gradient is negative 25 over 3 x. The y-intercept is 325 all over 27. This is the equation of a tangent where the graph changes its concavity. Y is equal to negative 25 over 3x plus 325 over 27. Okay, and then now we are told that if f of x is equal to k, has one distinct real root, determine the values of k. These things of k, guys, whenever you are dealing with your cubic graph, it's very, very simple. It's unlike whenever you are dealing with your parabola or your quadratic function rather. Just draw a line. If you can draw a line, guys, between your turning points, you can see that you get 3 distinct roots together. But if you draw a horizontal line at the turning point, you just have one root over there and one root over there. Né? But remember that, guys, this graph continues until positive infinity. So, but if, guys, you draw a horizontal line above your turning point, you'll only have one root. And if you draw a horizontal line below your turning point, you'll only have one root. So this simply means, guys, okay, k should be greater than our maximum value, which is just 500 over 27, or k should be less than our minimum value, which is 0. Remember that, guys, over there I get my y value at maximum, or rather the maximum value, and then over there I get my minimum value. So k must be greater than the maximum value. The maximum value is this one. You can write it like this or write it like me as a proper fraction. And then the minimum value is that one over there. Y is 0 at the x-axis. So k is greater than the maximum value, or k should be less than the minimum value. Okay, now I'm looking for the values of x where for which f of x is positive, for which f of x is greater than 0. F of x, guys, will be greater than 0 if and only if my graph is above the x-axis. If I can check here, from the right-hand side of A, my graph is will be forever above the x-axis. The only difference will be whenever my graph reaches point B. Are you together? My graph is not above the x-axis over there, but my graph is at the x-axis. So this entire region is true. Like I can see that my graph f of x, y will always be positive over here. Y will always be greater than 0, apart from the place whereby the graph turns at the x-axis. So for me to express this answer over there, I can simply say x is just in between -2 and 3. Vice versa, rather, -3 and 2. Remember that the x value over there was just -3, and the x value at B, there's 2 and 0. So between these 2 points, my graph is above the x-axis, and also whenever the graph is greater than 2, my graph will simply be above the x-axis. So that's how, guys, you could have tackled that question over there. So please do stay tuned and wait for more videos. Thank you.